In this video, I'll solve some questions based on assertion reasoning. Class 10th topic is limits. So in the assertion, it says that limit x tends to 0, 3 raised to the power 2 plus x minus 9 over x is equal to 9 log 2. So let's see if I solve this. I can write 3 square. Applying laws of exponent, I can write this as 3 square into 3 raised to the power x minus 9 that divided by x where limit x tends to 0. Now this is 9 only. So if I take 9 common, I'll get what? 3 raised to the power x minus 1 that divided by x. And this is limit x tends to 0. Now what we can see here that if I take out 9 outside, then it is as it is independent of x, limit x tends to 0, 3 raised to the power x minus 1 over x, which is equal to 9. Applying the identity over here, this is 9 log 3, right? As you must be doing that. A raised to the power x minus 1 over x, limit x tends to 0 is equal to log a. So it's log 3 here, 9 log 3. When I see here, it say it is 9 log 2. So clearly the assertion is wrong. In that case, the option will be D. In the next part, this is what the assertion. Now, in the assertion, I can see that if I have to solve it, if before evaluating, it's in the form of 0 by 0. So we are going to simplify it by converting 1 minus cos 2x as 2 sine square x, right? And there is an under root over here. So on further simplification, we say that limit x tending to 0 e raised to the power x minus 1. And if I take out, this is 1 by root 2, I can take out 1 by root 2, right? And this is sine x. We'll get this as sine x. Further, what I can do here, this is 1 over root 2, limit x tends to 0, e raised to the power x minus 1, dividing by x, right? Dividing and multiplying by x, we'll get this. So on solving, you will get this as 1 by root 2. On placing the limit, you'll get 1 into 1. As it is an MCQ, so you do not need to show the working. So we are getting 1 by root 2. So assertion is correct. Now coming to the reason, I can see that it can be factorized. Again, it is in the form of 0 by 0. So we must need to factorize it. So if I reduce this, what we are getting? X plus 1, right? And here the limit x tends to 1, not 0. So if I plug in x as 1, we are getting 1 plus 1, that is equal to 2, and is saying 1. So here the reason is correct. So in that case, the correct option should be C. In the next part, you can see here that we have a assertion as limit x tending to 1, x minus 1 log e x, right? Log x to the base e is equal to 1. So let's solve this. What we need to do here, that we can put say x is equal to 1 plus y. So it means as x tends to 1, y tends to 0. So we can write this as limit y tends to 0. Right. And this what we'll get here. This as replacing x with 1 plus y. So it's 1 plus y minus y over. This is going to give you log 1 plus y. So log 1 plus y, this get cancelled. So you can further see that this is limit y tends to 0. And I can write this as y. I can reciprocate it, right? This is log 1 plus y over y. So this will give you 1 here. This is what they're saying. So this is correct, right? So the assertion is true. Look for the reason here. Now on simplification of the reason, I can see we need to, this is log sine x plus 1 over x. Clearly it is in the form of log x plus 1. So what is missing here is sine x. So you can multiply divided by sine x. So sine x into sine x. Now rearranging them, if I write limit x tends to 0, log sin x plus 1 over sin x, and then is equal to or into, say, sin x over x. Now, since x tends to 0, sin x tends to 0. This way, this will give you 1, and applying sandwich, you'll get this 1 again. So 1 into 1 should give you 1. Let's say it's saying 0. Therefore, assertion is correct and reason is false. Therefore, in that case, C is the correct answer. Now, proceeding to the next question, we have assertion as 3 raised to the power x minus 2 raised to the power x over x, right? So simplification for this part is what we need to write down. For the assertion part, I can write this as limit x tends to 0. This I can write 3 raised to the power x minus 1 and minus 2 raised to the power x minus 1, and that divided by tan x, right? On simplifying, you will get this only. After that, what we need to do is to divide and multiply. So let's say limit x tending to 0, I can write this as 3 raised to the power x minus 1 minus 2 raised to the power x minus 1, that divided by x, and we can multiply it by x as well. So we are getting this. Now splitting this, the first term, this can be written as 3 raised to the power x minus 1 over x, and this is 2 raised to the power x minus 1 over x. And I can write this as 1 over tan x by x. I'm not writing limit, although in your examination, if it is not an objective questions, you must show the limit also. So as of now, I am not showing it in every step. This is limit x tends to 0. So this is going to give you log 3. This would give you log 2, and that multiplied by applying sandwich, we can write this as you know, tan x by x is 1. So this is going to be 1. So this would give you log 3 minus log 2, which is log 3 over 2. That is log a minus log b is log a over b. So we got this as log 3 by 2. That's the assertion, and I can see assertion is correct. Now going for the reason here, we have this information given here, that is, this is log 1 plus x over tan x, right? So what I'm doing, same way, I'm multiplying, dividing by x, right? I'm not writing the question here. This is limit x tends to 0. Clearly, for the first part, you'll get 1, and for this also, you'll get 1. So 1 into 1 is 1. When I see the option, it is saying 2. So therefore, the reason is incorrect. Assertion is correct. So C is the correct option in this case. In the next part, we have assertion as this. So in this assertion, I can see that it can be solved like by taking e raised to the power sin x as common. Keeping in mind, we are going to get this as in the form of e raised to the power x minus 1 over x. So therefore, I took this as e raised to the power x sin x, e raised to the power sin x as common. So dividing by sin x, you'll get e raised to the power x minus sin x, right? And then minus 1 as sin x minus e raised to the power sin x minus e raised to the power sin x is 1. Denominator will be as it is, that is x minus sin x. Now consider this to be, say, y, and this as y. So what you are going to get here, applying limit, you'll get e raised to the power 0 over here, and applying the formula of the limit, you'll get 1 here. So e raised to the power 0, which is 1. So 1 into 1 is equal to 1. Well, I can see that the assertion is false, right? So we don't need to see the reason, as you know, that in that case, whenever the assertion is incorrect, right? So the D is the correct option in that case. In the next, we have limit x tends to 0, assertion as limit x tends to 0, e raised to the power tan x minus 1 minus tan x. So clearly, it is in the form of e raised to the power x minus 1 over x. So let's see how we can simplify it. So this is limit x tending to 0, e raised to the power tan x. This is raised to the power tan x minus 1 over x. So we'll divide it and multiply it by tan x Right. So if I need a tan x over here, right? So this is what I need to do. So if I write, let's say first I write tan x over here and a tan x over here, multiply, divide, and this x, I'm writing it here. So this is going to give you 1 and this is 1. So this is 1 into 1 will give you 1. So assertion is correct. Let's check for the reason here. For the reason here, we have limit x tends to 0, e raised to the power 4x minus 1 over x. So I need to make it 4x. So I did multiply divided by 4. So this part will give you 1 and this is 4. So this is saying 2. So what will say that assertion is correct and the reason is false. So C will be the correct option. In the next question, this is our assertion. Clearly, a question of this type is simplified by first writing this in the form of 1 over e raised to the power x over x. And if I take LCM, I'll get e raised to the power 2x, same basis multiplied, power added. So that's why it becomes 2x minus 1 that divided by e raised to the power x. And we have an x here. Now what we can do here that we need 2x and that's why I'm rearranging them. This is limit x tends to 0, e raised to the power 2x minus 1. And this x becomes 2x if I multiply divide by 2 and that divided by e raised to the power x. Now applying limit over here, I'll get 1 and applying limit over here that is 2 e raised to the power 0. As you know, any number raised to the power 2 e raised to the power 0 is 1 here. So that is 2 over 1. So that comes out to be 2. I can see assertion is correct here. Right. Now, when we do the same thing with the reason, this is a direct substitution of the formula that is e raised to the power x minus 1 over x. So we can say even the reason is correct. And the explanation is this only, right? This is the correct explanation of this particular assertion. So we'll say in that case, A is the correct option for this. Proceeding with the next question, we have this as the assertion. So let's first simplify it. As we can see of the questions of this type, I need to take e square, e raised to the power 3 as common, right? I'm taking e raised to the power 3 as common. So what we'll get if I take e raised to the power 3 as common, that means dividing this by e raised to the power 3, right? So this is become e raised to the power x, and this will turn out to be minus 1. And that minus and minus sin x is left. And then whole divided by x. Now I'm splitting the applying limits separately. So let's e raised to the power 3 as it is independent of x. We can write outside the limit. This is e raised to the power x minus, and this is sin x over x. We can apply a separate limit for this. That is limit x tending to 0. This is sin x over x. Now this is going to give you 1 and this is minus 1. I did some mistake. Let's say 3 is outside, right? And yeah, clearly I can see there is this e raised to the power 3 only is with this and not with this. So common error observed in this kind of question. So this is e raised to the power 3, which is independent of x, and this is going to give you 1, right? So I mean to say that this part, right, will get 1 over here. So replacing this with 1 minus, this is 1. So it is e raised to the power 3 minus 1. So I think this is coming e raised to the power 3 minus 1. Well, the assertion is incorrect. In that case, the option will be D only. On the next part, we'll start with the assertion here. So what we need to do is to split this. So I'm writing this as limit x tends to 0. This is ax. I'm dividing by dividing numerator and denominator by x. Why? Because I need to get rid of this x here. That is this cos x, because it is in the form of 0 by 0. And so I'm doing with the denominator, that is divided by x. So this get cancelled here. As you can see here, x and x would get cancelled. This x get cancelled here. So then our numerator left over here will be limit x tends to 0. That is a plus cos x. A plus cos x. and that divided by b multiplied by sin x over x. Now, applying the sandwich formula and placing the limit, you know that cos 0 is 1 here. So you'll get a plus 1, and this is b multiplied by 1, right? So this is a plus 1 over b, and I see that assertion is correct. Now, looking for the reason here, in this case, it is x sec x, right? And this is limit x tends to 0. Well, cos 0 is 0, right? Cos 0 is 0. So 0 into sec 0, and sec 0 is 1, right? So that is 0 is the correct answer, and I can say reason is 1. So assertion is correct and the reason is wrong. In that case, the option will be C in this case. Assertion reasoning, this one is based on trigonometric identities. So needless to say, we are going to split here applying 1 minus cos 2x as 2 sine square x. So limit x tending to 0, right? This will be 2 sine square x, right? Because it is x, so 2x, so 2x becomes x, right? Half angle property. And this will become 2 sine square x over 2. So 2 get cancelled. Right. And then by dividing both of them by x square, I'll get this as sine square x. So dividing by x square here mean to say that to apply sandwich formula, this is sine square x by 2 divided by x square. So what else we are going to do is to multiply by 4 here, right? This by 4 and 4 here. This is done so as to make it x by 2 whole square. So this is sine the square x by 2, and I can write this as x by 2 whole square. So we can club them together in a single bracket and write x by 4 as x by 2 whole square. And we have 1 by 4 here, right? So 4, this on transposing, this is 1 by 4 for this, right? So if it is 1 by 4 in the numerator, it's 4 in the, it's 1 by 4, sorry, is in the denominator, right? This is 1 over 4. So this I can write 4 over here, 4 over here, right? Limit x tends to 0. As you know, when x tends to 0, x by 2 also tends to 0. So in that case, we are going to get this as 1. We will get this as 1. This as 1. 1 square is 1 only, obviously, and this is 4. So it is coming 4 here, but they are saying 1. So that's the reason we'll say that here the assertion is correct and the reason is false. So C is the correct option. We have this as the assertion, that is sine ax by sine bx, limit x tending to 0. So sine ax, I'll divide it by first, say, okay, I'll divide it by ax, then I multiplied by, say I multiplied by bx. Now better understanding will come like this. Say if I divide it by, say, x first, and both the numerator and denominator, it's just that I'm writing a division sign over here. So I've divided this the numerator by x and this the denominator by x. Now what I can do here is further, I can multiply by a here, multiply divide by a, and so I'm doing over here. Sorry, this is b. Now on further simplification, you can clearly see that over this part we can apply, sorry, over this part I can apply sandwich formula. So that will give you 1, and same over here as 1. So it will be a divided by b, which is a over b, and that is correct. And the reason is sin x over x, limit x tend to 0 is 1. So even the reason is correct and is the correct explanation. So therefore A is the correct option for this. In this next question, we have this as the assertion, limit x tending to pi sine pi minus x over pi minus x. If you remember solving textbook questions, we generally put pi minus x as say h or y, as you know that as x tends to pi here, y tends to 0. So now our question will change, replacing this x with, I'm going to replace x will become, what's that, x will become pi minus y. This is x, right? X will become pi minus y. So this will become what? This is sine. I'm writing the assertion part from here, from here. So we'll say that this is limit. Now it's limit y, sorry, I took y. So y tends to 0. This will become sine. This replaced with y, as you can see, this is y only from here, right? What I did here is, yeah, this is pi minus x, right? So yeah, that's going to be sine y over y. So that is equal to 1. And then there was a pi also that I missed here. So it should be pi. And if I remove this, I write this pi before it. So it's going to be limit y tends to 0. This is sine y over y. So this is 1 over pi into 1. That is equal to 1 over pi. Now they say that it is equal to pi, so that's wrong, right? So here we can say that the assertion is false. As you know, with the standard options given here, the assertion is wrong. We say it's D is the correct option. In the next part, we have the assertion as sin x over sin ax plus bx over ax plus sin bx, where limit x tends to 0. They are saying it is equal to, the question says equal to -2. So let's check it. In such a situation, we divide the numerator and the denominator by x. So what you are going to get, this will become sine. The numerator will turn out to be sine ax over x. Let's say if I show the proper working over here, that's x. This is ax over x plus sine bx over x. And this is limit x tending to 0. Now, what you can see here that we can get this as 1 if I multiply divided by 1. So I should write a over here and a over here. This x get cancelled. This x get cancelled over here. And if I multiply b and a b over here, so what we are going to get here, this part, this you'll get 1. This you'll get 1. This you'll get 1. So in turn, what we are getting here is, that is a into 1 plus b, and below it's 1 plus b into 1. So this is finally it's a plus b over a plus b only. Yeah. So that is equal to 1, right? And they are saying -2. So no need to check the reason here when the assertion is incorrect. And the default options are this only: assertion false and the reason true. Or maybe reasons true or not. We don't actually check it. With the standard option given, it should be D. So in the next part, we have this assertion sine ax over bx, limit x tending to 0 is equal to a by b clearly. So we have this as sine ax over bx, limit x tends to 0. So we'll be dividing by ax, right? So if I divide by x, not by ax, so this is by x, and this bx over x, right? So we see that these x get cancelled, and further we can multiply by a and a over here. So it's going to be what? This if I divide it by multiplied by a, so clearly we will find that this part is going to give you 1, and below there is a b. So it is actually a by b, right? That is equal to a over b, and that is what the assertion says, a by b. Well, what we applied is sin x by x is equal to 1, so it's a correct explanation as well. So a is the correct option in this case. In this question, the assertion is limit x tends to 1, ax square plus bx plus c, cx square plus bx plus c. As I can see, it's a polynomial functions in the p by q form. So what we rational functions, but the numerator is polynomial and denominator is polynomial. Let's check what we'll get if I plug in x is equal to 1. So 1 square is 1, and this is 1, and this is c. So we'll get the numerator by substituting x as 1. We are getting a plus b plus c, and below it is c plus b plus a. Yeah, they are the same. So we should get 1 here. Right. Now the assertion is correct. Now let's come to the reason here. The reason I'm simplifying, if I take LCM over this part, I'll get this as 2 plus x over 2x into 1 by 2 plus x, or x plus 2 is the same thing. So this get cancelled, right? This is getting cancelled, and we have to place limit x as -2. Fine. So this is limit x tends to -2. And if I replace this with -2, that is x as -2, is not in the form of 0 by 0 or infinity. So it will be -1 over 4. And this is also correct. So no, this is 1 by 4, right? So therefore, reason is incorrect. So in that case, you should write C as the correct option for this.